Hi there. Ever wondered why funding agencies, publishers, and institutions insist for scientists to openly publish their research data? You've put your heart and brain in doing a great job. You leverage existing resources for exciting discoveries. You plan for it and made your project to be as streamlined as possible. And you took care of organizing your dataset. Now, let's talk about making them available to other researchers so they can use them, seed them, and advance science along with you.
When your data or code is published in a fair way, which is to say it is fundable, accessible, interoperable, and reusable, then it is easier for other researchers to find, use, and cite your research. But it is also a way to open the door to fruitful collaborations. This goes beyond the publication of papers because one can find your dataset first. By disseminating your data in code, you are not only complying with some funding agencies, journals, and institutions, but you are enabling the entire scientific community to move the field forward. This gives real added value to your work. How to cross-reference your paper, data, code, maybe also your protocols? DOI is the answer. The Digital Object Identifier is the best known among permanent identifiers, a unique address for your work online. It makes it easy for other researchers to cite you correctly in their work. It ensures direct and secure access to your results, no matter how much time has passed. Having a DOI is a great way to ensure that your data is properly assigned and referenced. It also makes it easy to cite your data when publishing papers, for instance, with data or code availability statements.
Can you briefly describe what the Masonry Shake Table database is?
So let me first explain you briefly what a shake table test is. So in shake table test, we subject buildings constructed in a laboratory to a seismic signal in order to try to replicate what could happen in reality. When we talk about experimental test, especially shake table test, we are referring to a really valuable source of data, and very expensive, by the way. For the earthquake engineering field, these are probably one of the most reliable ways to understand how full buildings respond to earthquakes, but without the need to wait for a real earthquake to happen. Our goal is to make these results easy to access and reuse for the wider research community. We truly believe that open data plays a key role in advancing knowledge and fostering collaboration. That is why we created the Masonry Shake Table database, an open access platform that brings together experimental data from over 70 full-scale unreinforced masonry buildings tested in the over last 30 years.
Could you describe, in few words, the process your data have been through to be published?
The first step was to carry out an extensive search through the literature and organize the test based on how much data was available and how complete it was. Since the way experiments are documented can vary a lot from one campaign to the other, the next step was to define a clear set of metadata, basically the key pieces of information needed to make the data useful across different studies. We work closely with colleagues who use this kind of data to agree on what that should include. After that, we extracted this metadata from each experiment and started by organizing everything in a simple Excel file. Once we had that, we harmonized the data using the FAIR principles so it could be easily shared, found, and reused by both researchers and engineers. Then we focus on creating a user-friendly but also visually interface to help users quickly find and explore the experimental data they need. We paid particular attention to ensuring the data was well organized, consistent, and documented in a way that makes it easy to understand and reuse, following the FAIR principles so that others can find, access, and work with the data effectively. Also very important is to keep it continuously updated, thus keeping the users informed with the latest research done in the field and boost their interest and engagement.
Did publishing your data lead to new collaborations or unexpected opportunities?
Absolutely. And actually, that was one of the parts I enjoyed the most about this project. After we published the initial version of the database, we decided to take it a step further by adding numerical models for many of the buildings that were included in the database. This opened the door to collaborating with other researchers who are using different and innovative modeling approaches. Soon, we will be able to also compare results across different methods, which will help us move toward more reliable tools for making informed decisions, and especially when dealing with major events like earthquakes.
So why keep your research in a corner when you can publish it in advanced research? By publishing your data and code with a DOI and on suitable platforms, you ensure the visibility and reusability by other researchers. This gives your work a real reach and allows science to progress. Thanks for watching, and see you soon for more tips on managing research data.